Hello students, today we will study the chapter waves. This chapter explains how energy travels from one place to another without the actual transfer of matter. A wave is defined as a disturbance that transfers energy from one point to another without transferring matter. This means that when a wave moves forward, the material particles of the medium do not move forward with it. They only vibrate about their original or mean positions. In wave motion, energy is transferred through the medium in the form of oscillations. Each particle of the medium receives energy, vibrates for some time, and then passes the energy to the next particle. Thus, the wave progresses forward while the particles remain almost at the same position. Based on the requirement of a medium, waves are divided into two main types: mechanical waves and non-mechanical waves. This classification helps us understand whether a medium is necessary for wave propagation. Mechanical waves are waves that require a material medium for their propagation. They cannot travel in the absence of a medium. The medium provides two important properties: elasticity, which helps particles return to their original position, and inertia, which allows particles to continue vibrating. Examples include waves on water and waves on a stretched string. Non-mechanical waves do not require any material medium. They can travel even through vacuum. These waves are produced by oscillating electric and magnetic fields and are also known as electromagnetic waves. Examples include light waves, radio waves, and X-rays. Waves can also be classified based on the direction in which particles vibrate relative to the direction of wave propagation. On this basis, waves are divided into transverse waves and longitudinal waves. In transverse waves, the particles of the medium vibrate perpendicular to the direction of wave propagation. This means that if the wave travels horizontally, the particles vibrate vertically. Such waves are common in solids and on the surface of liquids. Transverse waves have two characteristic features called crests and troughs. A crest is the highest point of the wave, and a trough is the lowest point. These features repeat at regular intervals as the wave moves forward. In longitudinal waves, the particles of the medium vibrate parallel to the direction of wave propagation. Here, particle motion and wave motion are in the same direction. Such waves generally occur in elastic media. Longitudinal waves consist of alternating regions of high density and low density. As the wave passes, particles come closer together in high density regions and move farther apart in low density regions. These regions move forward while particles vibrate about their mean positions. Wavelength is the distance between two nearest points that are in the same phase of vibration. It represents the length of one complete wave. Examples include the distance between two consecutive crests or two consecutive high-density regions. Frequency is the number of complete vibrations or oscillations made by a particle in 1 second. It tells us how frequently particles of the medium vibrate. Higher frequency means faster oscillation of particles. Time period is the time taken by a particle to complete one vibration. The relation between time period and frequency is time period equals 1 divided by frequency written inwards. This shows that frequency and time period are inversely related. Amplitude is the maximum displacement of a particle from its mean position. It indicates how far the particle moves during vibration. Greater amplitude means that the wave carries more energy. Wave velocity is the distance traveled by a wave in 1 second. The relation between wave velocity, frequency, and wavelength is wave velocity equals frequency multiplied by wavelength, written inwards. This relation is valid for all types of waves. In wave motion, particles do not move forward permanently. Only energy is transferred, particles oscillate about their mean positions, and for a given medium, frequency and wavelength are inversely related. In this chapter, we studied the meaning of waves, types of waves, transverse and longitudinal waves, and important wave quantities such as wavelength, frequency, amplitude, and wave velocity. These concepts are fundamental for understanding many physical phenomena in physics. Jai Hind.